Okay, let's unpack this.
Yeah.
So what happens when you have this massive bandwidth need?
Like a huge one.
Exactly, like, say, 4 simultaneous, uncompressed, high-def video feeds.
Right.
But your budget, your logistics, they only allow for one single, skinny fiber optic cable.
That's the problem.
That trade-off right there between the data volume and the infrastructure burden, that's really the core challenge our deep dive is going to tackle today.
They were aiming for pure convergence. Our source material is all about the specialized hardware built to solve this exact problem.
And that would be the Thor Broadcast F-4SDI-3G-GET kit.
That's the one. The mission is basically to get rid of separate network infrastructure entirely. You take 4 high-quality video signals.
And these are 3G-SDI, so we're talking uncompressed, high frame rate HD video.
Precisely. You take those plus a full gigabit network, and then you transmit all of it across huge distances.
All over a single thread of fiber.
That's where the workflow benefit is just, it's huge. It means a small field crew, they only need to run one cable.
Which is the definition of efficiency. You can just imagine like a video camera at some remote event.
Yeah.
And it's sending that live 3G SDI footage all the way back to the central studio.
And at the same time, that single fiber is also extending your existing local area network.
Okay, so a PC controlling the camera, or maybe a router managing comms on site.
Anything. It can send and receive data over the exact same link. It's 2 totally different, really demanding workloads.
Real-time video and bidirectional network data.
Merged effortlessly.
And the distances here they're incredible.
Yeah, depending on the model, you can span 20, 40, all the way up to 120 kilometers.
That's like piping 4 live news feeds and a local network between 2 major cities on one little thread of glass.
And at those links, signal purity is paramount, especially with that high bitrate video.
It has to be perfect.
So a key engineering nugget in the sources is the inclusion of input equalization and reclocking.
So this isn't just a simple booster then?
Not at all. It actually cleans up any timing jitter, any degradation that happens over that long haul, and it ensures the video signal stays clean and stable.
And it keeps all the metadata, right?
Critically, yes.
Yeah.
It passes all the SDI embedded audio and the ancillary data without any loss.
Okay, now let's break down this network side, because there seems to be a very deliberate design choice here.
There is.
It handles standard gigabit Ethernet, 100, 1000 millips. But the sources, they really stress that it works as an unmanaged pass-through transceiver.
Right.
But wait a minute. If we're dealing with an 80-kilometer link, wouldn't avoiding management make troubleshooting, way harder?
That is a fantastic question, and it speaks directly to simplifying field deployment.
Okay.
This system is, and this is on purpose, it is not addressable with an IP address.
No IP address. So what does it do?
It just simulates a simple physical Ethernet extension cable. It basically cuts network configuration completely out of the process.
So the crew doesn't need to touch routing tables or anything?
Nothing. They extended their existing LAN seamlessly.
So the trade-off is this.
Yeah.
You get massive simplicity for the field crew, which is great.
Mm-hmm.
But any complex traffic control, any quality of service prioritization, that all has to happen on the network gear at either end of the fiber link, not in the device itself.
Exactly. And it makes sense as a conscious decision for, speed of deployment.
It does.
And the foundational technology that even allows for this level of signal convergence is CWDM.
Coarse wavelength division multiplexing.
That's the one.
Which, for anyone quickly curious, is basically the process of using different colors of light different wavelengths.
Yep.
To send all those individual video streams and the data stream down that single strand of fiber at the same time without them interfering.
Precisely. And its compatibility with standardized CWDM bands, from 1271 millimeter up to 1611 millimeter. That means it integrates easily with massive existing CWDM systems.
Like a Python system or something similar.
Exactly. This inherent flexibility allows for customizable capacity too, supporting bidirectional transport of up to 16 total channels.
Way beyond the initial 4 video feeds.
Way beyond.
So when we wrap this all up, what's the big takeaway? I mean, this deep dive really shows us a masterclass in professional broadcast engineering.
It does.
It's all about prioritizing that high bandwidth convergence, the signal purity, and doing it with minimal infrastructure.
All achieved with one tiny fiber link. This device is, it's a triumph of clever engineering. It unifies all these complex signals onto a single thread of light.
Yeah.
Which brings up an important question for you listening at home.
Yeah.
In a world that is so fixated on wireless, on 5G and satellite links, what critical real-time applications,
Where there's no room for error.
right, where guaranteed stability and ultra-low latency are just non-negotiable, what applications will always rely on the dedicated speed and reliability of a fixed physical fiber optic cable?
Something to think about the next time you watch a crucial live event.